Hello friend, I am Ghanshyam and welcome to the Electrical Neuron. I am here with taking a new video on inductance of composite conductor. So previously we have discussed the inductance of self-inductance and mutual inductance and flux linkage. Today we are going to discuss about the inductance of composite conductor. So friend, come to our topic. So let us know the inductance of composite conductor. So what are the our formula and what are the mathematical derivation behind the composite conductor, and what are the inductance of conductor A and conductor B. So let's see. So here we are now ready to study the inductance of transmission line of this two composite conductor. One is composite conductor A and another is composite conductor B. Okay, in this figure sign in 2.6. Such a single line composite conductor are having A having n number of conductor and B having m dash number of conductor or parallel filament. Okay, so through the inductance of each filament will be somewhat different. The inductance will be different, but here their resistance will be equal. Okay, remember that inductance will be different, that may be vary, but resistance will be same of the conductor. Because of the our conductor diameter and conductor length effect, the inductance will be vary. Okay, so it is sufficiently accurate to assume that current is equally divided among the filament of each composite conductor. Thus each filament of A take to carry of current 1 by n. So composite conductor of A carry the 1 by n amount of current, while the filament of conductor B it carry 1 by m dash minus of 1 by m dash of current. So applying the equation filament I, then therefore we will get, let me erase first, therefore we will get lambda I is equal to 2 into 10 to the power minus 7 1 by n into ln 1 by di1 plus ln 1 by di2 plus dot something 1 by ii then in. So how it will be formed? By the previous, from the flux linkage of one conductor in a group, there will be one formula like that. So from this, from conductor I, the formula that is like this: 2 into 10 to the power minus 7 1 by n ln 1 by di1. Di1 means the ith conductor linked, the inductance will be linked with the ith conductor, inductance will be linked with that conductor, that inductance will be linked with that conductor inductance, it will be linked with this, it will be linked with this. Okay, so here di1 di2 dii din, that means ii means self. Okay, so from this and that conductor in mutually it will link to I conductor is linked to I j dash, I conductor linked to 2 dash, I conductor linked to 1 dash, I conductor linked to m dash. So then our formula will be formed 1 by m dash of 1 by minus of 1 by m dash of ln di1, here it is shown 2 into 10 to the power minus 7 minus, because of the minus of 1 by m dash, ln 1 by di 1 dash plus ln 1 by di 2 dash plus like that di m dash, whatever the conductor placed over here, that much of ln. So by calculating this by one formula, that is ln the formula learn something minus learn something, that is equal to learn that divided by that. Yes or not? It is the formula. So by apply this formula only, we will get 2 into 10 to the power minus 7 ln di1 di2 dim dash. So this denominator will come over here with 1 by m dash because of this current, and the denominator case over here. So this denominator is here, and its unit is Weber term per meter. This is flux linkage. So we know the flux linkage formula and relation between the inductance, that is flux linkage lambda is equal to L into I, and inductance is equal to flux linkage lambda divided by current. So for ith conductor, for filament I, we taken the current, that is 1 by n, and that to 1 by n, this is our formula, 1 by n. L is equal to flux linkage divided by 1 by n. So is equal to 2n into 10 to the power minus 7 ln di1 dash dij dash dim dash to the power 1 by m dash divided by di1 dii to din 1 by m Henry per meter, the unit of inductance. Okay, I think it is clear to you. If not understood, then please ask me on the comment section, then I will clear your doubt. Okay, so we know the average formula. So the average inductance of filament of composite conductor, that is A. For composite conductor, that is L1, L2, L3 to Ln divided by nth number of conductor. Whatever the conductor, divide that conductor. Okay, since conductor A is assumed of n number of filament electrically in parallel, its inductance is L average divided by n. Its inductance is L average divided by n. So 1 by n into 1 by n, that is n square. So here L1 plus L2 plus Ln divided by n square, using the expression for filament inductance from equation 12.31. This equation inductance from this and this equation, by comparing this, we will get LA, inductance of composite conductor A, is equal to 2 into 10 to the power minus 7 ln, that is self, upper one is self, that is numerator is self inductance and denominator is mutual one. Okay, so I think it is no, denominator is our self, and this term is our self inductance, and this term is our mutual type. Okay, so 2 into 10 to the power minus 7 ln di I dash I to j dash I to m dash to I to 1 dash I to j dash I to m dash, like that all the inductance, and this denominator self one. Okay, so here the overall formula, L is equal to 20 to the power minus 7 GMD divided by GMR, geometric mean diameter divided by geometric mean radius, and this is our formula. So I think it is clear to you. If not clear, then ask me. Okay, and please share to your friends so that they are also benefited to this. Thank you for watching.